Hello dear students, welcome to the TEQIP Faculty initiative of Let's Crack the Gate. Welcome to the classes of Power Electronics, AC/DC Rectifier. So today's topic is effect of source inductance on single phase AC/DC rectifiers. So let's begin today's topic. So we are going to study today about the effect of source inductance. Let us say it is Ls on one phase AC/DC rectifiers. Okay. So, when we talk about the effect of source inductance, till now we have studied that we were taking that the current was transferring or commutating from one device to another device instantaneously, because we are neglecting the effect of source inductance. But in actual what happens that source has got some impedance, it has got some resistance value, it has got some inductance value, all right. Just like for example, if you take a single phase AC source, if you are generating it through some generator, obviously it will be having some source inductance, all right. So now we are considering that effect of source inductance on the performance of AC/DC rectifiers. So let us start with very simple circuit, that is with half wave rectifier. Okay. So for studying the effect of source inductance, what we are going to do is that we are considering the load current as constant, ripple free. We are considering load current as means load current is constant, ripple free. Okay. So now let us take first case of half wave rectifier with freewheeling diode. So let us draw the circuit. Okay, so I am taking this as I naught. So this is the source Vs, this is freewheeling diode, and let us say it has got average output voltage V naught. This is main diode D, and let us make some source inductance here, this, all right. Now this is the source inductance Ls. Okay. So now is start its working, means how it is going to work. Let us say it is Is. Okay. So let us draw the wave. First of all, let me draw the input waveforms first. Okay. So this is our source voltage. So these are the instants. This is Vm 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. So let us start how it is working. So initially, if we consider, now let us draw the load current also. This is the load current which we have assumed as constant, and let us draw the voltage also, output voltage.
So, now what is happening? Let us start with the initial cycle, means from 0 to pi.
So, what is happening from 0 to pi, that this diode, main diode will be on and freewheeling diode will be off. So, what will be happening, that the load is in parallel with the source, then you will get the full output voltage. I am drawing it at full output voltage like this, which you get in the half wave circuit. Alright. Now, what is happening from means here the diode is on, freewheeling diode is off, no problem with this. Okay. Now, what is happening? So, yes, now we have also to draw source current here. So, I am drawing also the source current. Okay. So, we have to draw source, and instead of source current let us draw okay, let us draw diode current ID, and there is no space here. So, let me draw here, and we also draw freewheeling diode current. I freewheeling diode. So, now what will happen? So, here you can assume that the source current means the diode has instantly on. So, the current was flowing, although the source inductance does not allow it to means immediately rise up. So, how will the diode current will go? It will go like this, and then it will become constant. Okay. No problem with this. Now, what is freewheeling diode current in this space? In this duration, the freewheeling diode is 0. Okay. So, we are getting the output like this, for let us say we are getting for first half cycle like this. Now, what is happening from pi to 2 pi? So, if you see from pi to 2 pi, at pi instant the supply reversal takes place, hence diode will be immediately means it will be reverse biased, and freewheeling diode will be forward biased. If source inductance would not have been there, then it will be immediately off, this diode will be immediately off, and this freewheeling diode will be immediately on. But and immediately the load current will commutate from diode to freewheeling diode. But due to the source inductance, what will happen, that this source inductance does not allow instantaneous change of current or instantaneous reversal of current, whatever you can say. Alright. So, what will happen, that this I naught current which was flowing from diode D will gradually become 0, and this freewheeling diode current will gradually become increasing. Alright. So, if you draw the circuit will be like this, means this diode will remain still on because inductance does not allow instantaneous change of current, and this diode has also been on, okay, because of reversal of the supply. Okay, like this. Let me draw source inductance also here. So, what is happening here? One current is flowing from diode D, and this is freewheeling diode. So, what is happening, that this freewheeling diode current is flowing like this, let us say it is IFD, and the diode current is flowing like this. Okay. So, what is happening here? Sorry, not like here, this. Okay, like this. So, what is happening here, that the diode current is gradually decreasing and this freewheeling diode current is gradually increasing. So, what do you see here, that for little time means, if let me draw it like this. So, now the diode current will gradually decrease, okay, and the freewheeling diode current will gradually increase like this. So, you see in this duration, when both diodes are turned on, both are short circuited, it means output voltage during this period will be 0. Alright, output voltage will be 0 here. So, what is happening? You see that from here then onwards the diode current will be 0 and freewheeling diode current will rise up. Okay. So, this overlapping you see here, this overlapping is known as overlapping angle mu. Okay, this is known as overlapping angle mu. Now, what will happen then after this mu? Let me mark here. This is mu. So, from pi to mu, it is mu. From pi to mu, what will happen? This diode will still remain on. Hence, the voltage across diode will be 0. All right. Then after this, then the freewheeling diode will conduct, and the output voltage is 0. No problem with that. Then at 2 pi, what will happen? At 2 pi, again the freewheeling diode means if you talk from 2 pi to 3 pi, then the freewheeling diode will not immediately turn off. When the supply again gets reversed, the freewheeling diode did not get immediately turned off, and this diode will also did not get immediately turned on. So, what will happen? This circuit will be made again, and in that case now the freewheeling diode current will be decreasing and this diode current will be increasing. So, in this case what will happen? The diode current will go like this, and in this duration the freewheeling diode current will be decreasing like this, and after that again this is the overlap angle, this is mu, and after this mu, when overlap angle is over, then this freewheeling diode current will be 0 and diode current will be equal to I naught. Now, but what will happen during this duration from 2 pi to mu plus 2 pi, from this duration to this duration what is happening? And from this duration you can see that still the freewheeling diode is on. So, till the time freewheeling diode remain on, the output voltage will be 0. It means from this point to this point means from 2 pi to 2 pi plus mu, this point is 2 pi plus mu, the output voltage will remain 0, and after that output voltage will be like this. And then again at 3 pi, then again the diode will be reverse biased, hence its current will fall like this, and the freewheeling current will rise like this. Okay. So, again the output voltage will be 0, but again at this point what will happening? The diode current will be rising like this and the freewheeling current will be falling like this. So, at this point again you can see that again till this point output voltage will be 0, and after that there will be some output voltage. So, you can see that if you neglect this first cycle, this one, if you neglect this first cycle, the infinite cycles will be like this. Okay. So, you can see that due to the effect of source inductance, our output voltage reduces to some extent. All right. So, if you neglect this, you can also draw this waveform also like this. Like this. Okay. If you make the overlap angle. So, for the infinite cycles, we can also make the figure like this. You can see this figure in the book. Now, if you want to draw the source current, so obviously here the source current is equal to the diode current. So, whatever the diode current is flowing like, the source current will be like the same. Okay. So, now let us move to the next, that is full wave circuit, full wave diode circuit. What is happening there? Full wave diode rectifier. So, now for full wave diode rectifier, what is happening? Let us draw the circuit. Source inductance is there, and this is like, again I am taking constant current load. So, let us mark the diodes also, D1, D3, D2, D4. This is source Vs, source current Is, inductance L, Ls. So, now I start making the waveforms. let us say it is source voltage, this is load voltage, this is diode D1 current. You can say D1 and D4, they will be having same current. So, I am drawing only D1. Let us say this is diode D3 D2 current, okay. D2 and D3 will be having same current, or you can also put D3, it is much better. And then we have to draw the source current, okay. So, let us draw. So, these are my instants 0 pi two pi three pi four pi and 5 pi. So, mark it 0 pi 2 pi 3 pi 4 pi 5 pi and this is Vm. Okay. Now, see here, when let me again start with the initial cycle, that when the initial cycle means from 0 to pi, what will be happening, that diode D1 and D4 will be forward biased and you will get some output voltage. So, I am now marking output voltage with dotted portion like this, okay. And diode current D1 will go like this, okay. No problem with this for the time being. So, its value is I naught. Now, what will happen, and diode D3 current will be 0 and source current. Now, when D1 D4 conducts, it will be positive, and when D3 D2 conduct, it will be negative. So, let us say that the source current is going from like this, okay, no problem. Now, what will happen at pi to 2 pi? So, at pi what will happen, the supply gets reversed, means D1 and D4 will be reverse biased and D3 D2 will be forward biased. So, D2 D3 will be immediately turned on, but due to source inductance presence, D1 and D4 will not get immediately turned off. So, all right. So, what will happen, that D2 D3 will be also be on and D1 D4 will also remain on till the time that the current of D1 and D4 gets 0. So, you see that all the 4 diodes will be on in this circuit, all right, means are just after pi. So, let me draw the circuit, how it will look like. So, it will look like this. If you see, the circuit will look like this. This is source, all right. I am marking reference values. This is LS, this is D1, D4 and it is D2, D3. So, what is happening here? Although the I naught current is flowing here, so now here one current is flowing here, that is ID1, let us say ID1 current is flowing, and let us say here current is flowing ID3. So, what is happening here, that here one current is flowing in this loop, all right, and one current is flowing in this loop, all right, and one current is flowing in the outer loop. So, what will happen, these current, the diode D1 and D4 current, means this ID1 will be decreasing, all right, because the supply has got reversed here, and D2 and D3 means ID3 current will be increasing, this current will be increasing gradually. So, this current will be decreasing gradually and this current will be increasing gradually. But what will happen, since current is flowing from these diodes and these diodes also, so it will be like a short circuit, here also it will be short circuit. So, what will happen, all the 4 diodes are shorted together, it means what, that this load will experience a 0 output voltage. It means till the time, if you draw here, the diode current D1 current is decreasing gradually, means like this, and in the same duration diode D3 current is increasing gradually till I naught. All right. So, it means what, during this duration what is happening, that the diode current D3 current is in this what is happening, that these diodes are all shorted together, hence output voltage will be 0. So, in this case till this point the output voltage comes out to be 0, and again this is called overlapping angle or mu. So, if you want to calculate it from here, so this is overlap angle mu. All right. So, what is happening here, and what will be the source current? You know that when the diode D1 D4 conducts, source current is positive, and D2 D3 conduct, source current is negative. So, now source current will not become immediately positive negative, just like we have seen like this. No, now the source current will not be like this, but source current will be like this, that it will go from positive to 0 and then it will become negative. All right. So, source current will be like this, okay, it will be like this, see here. All right. So, now the source current which was earlier positive, now it will become now negative. So, it will means oscillate between plus I naught and minus I naught. So, now here, so as soon as the diode D2 D3 take over the conduction fully, D1 D4 will be totally turned off. So, when D1 D4 totally turned off at this instant, all right. So, what will happen, again due to D2 and D3, the output voltage will be equal to the source value, and that you know that it will come around positive, okay, and D1 current will be 0 and D3 D2 current will be positive. Now, again, and the source current will be negative. Now, again come to next instant, from 2 pi to 3 pi, what will happen, again at this point this same circuit situation arises again. What will happen, that D3 and D2 will not get immediately turned off, but D1 D4 gets turned on. So, what will happen, again this circuit will be there, and what is happening, that now the D1 and D4 current will be rising and D2 D3 current will be falling. So, what will happen here, that D3 current will be falling, okay, and D4 current will, D1 D4 current will be rising like this. So, in this case again what will happen, a shorting situation happens, hence the output voltage is again 0, okay, and when the output voltage is 0, you can see that source current will go from negative to positive like this. It is a exponential curves, sorry. Like this, okay, and after that the source current will be plus I naught, diode D3 D2 current will be 0 and D1 D4 current will be plus I naught. All right, and after this, when the mu interval is over, again mu is called overlapping angle. Let me write here, mu is overlapping angle. So, after this again the output voltage will be like this, and you know that when again from 3 pi to 4 pi the same thing will repeat. So, you can draw the waveforms like this. This is the source current here. You can see here, due to effect of source inductance, the current does not change instantaneously, you see that, all right, and also this affects the output voltage, that it results in another 0 output voltage, means it further reduces the output voltage, average output voltage value. So, if you consider this first cycle, this will never happen again. So, we can draw this first cycle like this only. So, we can draw here first cycle like this. So, that is why book people write that let us assume that D3 and D2 were conducting earlier, alright, they assume like that because of this only. So, here now D3 can be drawn like this, and this source current can be drawn like this. Okay. So, that is how this effect of source inductance happens in case of rectifier circuits. Alright. So, now let us take the case of this control rectifier full wave. So, let us take the case of full wave control rectifier. Full wave controlled rectifier. So, now draw the circuit. Circuit is not very difficult. Instead of diode, now we have to make thyristors. And it is our load. So, it is I naught and this is plus minus V naught, T1, T3, T2, T4, source, IS and LS. So, let us draw the waveforms. So, again we know that the same circuit will become like this, the circuit will be like this only. So, let me draw here only the circuit and we will continue with the waveforms. Thyristor T1, T4, T2, T3, and then the load current. So, either this supply voltage Vs, I am drawing the reference values only. So, let us say this is current IT1 or IT4 and this is current IT2 or IT3. Now, let us draw its waveform. So, this is our source voltage. So, we can see we have to draw a load voltage, we have to draw the thyristor currents IT1, we are drawing IT2 and we are drawing the source current IS. So, now let us make the waveforms. So, this is our source, Okay. So, now for these are thyristors since, so we have to draw the firing angle also. So, I am taking this as firing angle. So, let me mark 0, pi, 2 pi, 3 pi, 4 pi, 5 pi and so on, and let me mark the firing angle also. So, this is alpha, alpha plus pi, this is alpha plus 2 pi, and so on. Okay. Now, see here what will happen in case of thyristor, since we know that until unless we do not give the gate pulse, the thyristor will not start conduction, will not come into conduction mode, they will remain in the blocking mode. So, let us start with the initial of the cycle when the cycle is first starting. So, means at alpha means from 0 to pi means 0 to alpha all thyristors are off, alright. So, we know the theory, only we are considering what will happen at the LS part. So, we know that from so at the starting of the cycle we can say that the output voltage will be like this. Okay. Let us say the output voltage is like this, and since the load current is constant, so what will happen, the output voltage will go to negative, and the thyristor T1 current, T1 T4 current will be like this. Okay. Since from pi to pi plus alpha no other thyristor is available, no freewheeling diode is available, that is why these thyristors have to remain forcefully turned on. So, this means the thyristor T1 current will be like that and T2 current will be like this 0, and source current will also be, we can consider as positive, because we know that when T1 T4 conducts, the source current is positive, it will be same like this. Now, let us consider what will happen when at pi plus alpha T3 and T2 gets the gate pulse. So, when at pi plus alpha T3 T2 gets gate pulse, they will be turned on, but the current will not immediately commutate or transferred from T1 T4 to T2 T3 because of source inductance. So, what will happen? This will happen in this circuit, this will result in this circuit. So, here again we can see that one current will be flowing like this, one current like this, and one current will be like this. Okay. So, what will happen, that the current IT1 will be decreasing and IT2 will be gradually increasing. Why? Because T1 and T4 are facing reverse biased and T3 and T2 are facing forward biased. That is why T1 and T4 will reduce their current or decrease their current, and current in T3 and T2 will continue. But please mind, in above circuit also and in this circuit also, in first circuit also, in all the three circuits, the net I0 current will remain I0 only. Why? Because here if you see, here also the IT here, yes, here also the ID1 plus ID2 constitute total current I0, alright, and here also IT1 plus IT2 constitute total current I0. Okay. So, total current will remain same. So, what will happen here? Now, what is happening, that since all the 4 thyristors will be on, so what will happen, it will all the 4 thyristors short circuited. So, what will happen, this leg also shorted, this leg also shorted, what will happen, the output voltage will be 0. So, let us draw that IT1 is falling, and in this duration IT2 is rising. Okay. So, this is again our overlapping angle mu. Okay. So, IS will be, now what will be the IS? IS will fall from plus I0 to minus I0 like this. Okay. And in this duration, during overlapping, what will be happening? During overlapping, that the output voltage will be 0. Okay. So, we can draw like this, and when the overlapping period is over, again the output voltage will follow, because T1 and T2 are off now T3 and T2 will take the conduction. So, again the output voltage will be positive like this, which we know like this. So, here you can see that this one voltage is lost due to this negative area and another voltage is lost due to this 0, due to this overlapping area, alright. And again from here you can see that from 2 pi to 2 pi plus alpha, again this thyristor T2 and T3 are to forcibly remain turned on. So, there is no problem drawing like this, okay. Source current will also be like negative, but again at pi plus alpha plus 2 pi, what will happen? T1 and T4 will get gate pulse, and again this circuit will happen, and again due to source inductance the current will not immediately commutate for or transferred from T2 T3 to T1 T4. Again now in this case the T1 current will be rising because of forward bias and T2 current will be falling because of reverse bias. So, what will be happening, that T1 current will be rising like this and T2 current will be falling like this, okay. And source current will become from negative to positive like this, okay. So, and in this duration again the output voltage will be 0 because of the short circuit, and when this overlapping period is over, again the output voltage will be like this, okay, and then it will go negative, and again. So, this now you can understand, now this cycle will go on like this. So, we can make it like this. Okay. So, again you can see that this duration output voltage is 0 till here and here. So, what will happen if you neglect this first cycle of initial value and continue with the infinite cycles? How this cycle can also be drawn like this. Here it is 0, prior to that it must be negative, and then like this, and the IT1 current will be, means it is increasing. So, it must be like this, and prior to that it is 0, and IT2 was conducting priorly, and during this duration it will be 0, and what about source current? Source current must be negative, and then from negative it must move to positive like this. So, this is due to effect of source inductance we get this overlapping area. So, what this causes another reduction in the output voltage, okay. So, now we will continue with our this means in this source inductance. We can do its analysis also, alright. So, I am giving you as a task that please find out the average output voltage in case of source inductance, okay, and please post this answer in the comment section, because GATE people have given few questions based on the effect of source inductance also. So, for any doubts and queries, please post in the comment section, and how do you like the lecture, please also post in the comment section. Till then, thank you very much.